Good afternoon, everyone. So it's my great pleasure to be here. So today I will be talking about how we will enable anonymous MACI and also large-scale MACI round on DoraVolta and therefore on our Cosmos Appchains. Something I want to mention first is that MACI has already been enabled on Cosmos Blossom. If you do not know about that. Throughout the course of last year, I have been given a few talks about how MACI works and also how we implement MACI on Cosmos Blossom. So can I just assume everyone knows about MACI and I will just skip this part? Can I? All right, cool. I just want to mention that the way we implement MACI is under the principle that we want to use the most established and proven libraries so that we don't have to rebuild ZK libraries. So the sequence will be, we have the Bellman SnarkJS adapter, which verifies all the SnarkJS ZK on Bellman, and then we have the ZK Cosmos Blossom. And based on that, we had the first implementation of Cosmos Blossom MACI. So this is just not only for Cosmos Blossom MACI. So we hope that this is a very rapid and easy approach for anyone to build quick ZK applications on Cosmos Blossom. With that, because so for MACI, we have already been adopting MACI from DoraHacks for several years. The first ever MACI adoption on DoraHacks was 2021, and in 2022 there was the East Denver MACI round with a medium scale voting activity happening on Polygon. And after that, a few other hackathon communities adopted MACI in their judging and also open source funding. However, the implementation on DoraHacks is not universal. Something we're really interested in is to make sure that MACI is available for everyone. So if you are running a voting round, we want to make sure that all communities can use MACI very easily. But originally, using MACI was really complicated. And we did a few things to reduce the cost of using MACI last year. So the first thing we built on DoraVolta is a general and portable MACI interface. So we have the Explorer. So it's just Block Explorer, except this is a MACI Explorer. So it aggregates all of the MACI rounds happening on chain. And you'll be able to see every round and with detailed information. And the second one is from the operator's perspective, we have the user experience so that if you are a MACI operator, you can create and manage MACI round with this UI. And the next thing is a portable MACI voter front end. So the protocol is pretty universal, so you can just deploy the protocol on chain. Everyone can just use the protocol. However, the front end is not that portable. So if you're running your own MACI use case, you have to have your own front end. So this is not something we can just deploy for every use case. So the approach we did was to create an open source version of UI so that everyone can just build their own MACI UI based on our UI. So we call this portable MACI. It's already available. It's a minimalistic version of front end for MACI. Yeah, so this one is probably the most important one because the most complex part of running a MACI round is for the operator to actually do all of the work, because in a MACI round you have to prove that your published voting result is correct with zero knowledge proof. And there is a lot of work. So you have to prepare for the Z key. You have to download and decrypt MACI messages. You tally the votes. You generate ZK proofs. You generate ZK proofs for message processing and the tallying. And finally, you submit the proofs to the smart contract and verify that. So what we did is we provided an open source script that you can just do npm run tally, and the script will just run everything for you. So it goes all the way from the top to the final step, including publishing the results and verification on chain. Yeah, so that is DoraVote and MACI, and we did that last year, and a lot of people from the community were like creating test runs. Recently, we're seeing some more like real-world use case and adoption from the community. So this is an awesome hackathon just closed in Berlin. Like there are 2 judge tracking rounds did MACI. That was how it works, and it works pretty well. And what is happening now is just right now is following up the passing of Gov Proposal 917. So we deployed probably the largest MACI round in history. So we added 1.4 million people into a single MACI round. Like whoever staked Atom on Cosmos Hub around by May 27, 28, are in the round. So right now, I just checked like last night, there are more than 10,000 MACI messages already casted on chain. So this is definitely the largest MACI round happening in history. I'm super happy that this happens on Cosmos. Yeah, so this is about the infrastructure for MACI on Cosmos. So I'm going to shift to another topic, which is more important in the long term. It's about MACI trust assumptions. So if we think about MACI a little bit harder, we will realize that like the trust assumption is really about scaling. So there are 2 aspects of MACI trust assumption. One, we have the operator who cannot fake votes, right? That is guaranteed by the zero knowledge proof itself. Otherwise, you cannot provide the correct one. And second, the operator can actually collude because the operator knows of the votes. The votes are encrypted with the public key from the operator, but then the operator knows everything. So this really prevents MACI from scaling. So something that is important to this protocol is that we have to implement anonymous MACI. So anonymous MACI is MACI with unconditional trust. So the very simple idea of implementing anonymous MACI is to add a very simple operation called deactivate key. So we allow users to deactivate their key and register a new key after that. So if we somehow can make sure that the operator, like after some maneuver and the operator doesn't know like who deactivated what key and who registered what key, like the operator can be confused, we succeed, right? So that is like the basic idea of anonymous MACI. But how do we achieve that? So obviously there are like 2 challenges. On the operator side, the operator has to maintain a set of deactivated keys and a nullifier set so that she knows which keys to have been deactivated and which keys have been re-registered. And on the voter side, a simple idea would be just for the voter, if you don't want the operator to know like which key has been deactivated, you can just provide a zero knowledge proof so that the keys, like you don't tell her like which key you have been deactivating, and if like there are more people doing that, the operator will be confused. However, if that is the case, the operator has to release the deactivated key set to the voter, which breaks the anti-collusion feature. And MACI is not going to be collusion-free anymore. So this is like a dilemma we have to address here. The implementation of anonymous MACI actually solves this problem. The very first idea came from Kobe. That is not the first idea, but that is the idea we actually implemented on. So the idea is that from the operator side, we will allow the operator to update a withdrawal set, which is the deactivated key set. But instead of just like injecting the keys into this set, we are making each element a tuple. And the tuple second element will be the key status, but encrypted with the operator's public key. So that if, like, from the public's view, you see a bunch of tuples, you don't know like which key is actually deactivated. And from the user side, whenever you register a new key, you have to provide a zero knowledge proof for three things. First, you have to prove that you own the private key of the public key you deactivated. And second, there has to be a corresponding deactivation record from the withdrawal set. And third, you're going to re-randomize the tuple you're submitting with some re-randomization encryption algorithm. So let's say you have C1 and C2, and you are re-randomizing that to D1, D2, but you prove that D1, D2 is re-randomized from C1, C2, and when the operator receives that re-randomized tuple, she will be totally confused. But you can prove that it is actually from some C1, C2, right? So this is a process. And lastly, the operator has to maintain a nullifier set, which guarantees that like every deactivated key only has generated one new key instead of multiple ones. So if you're interested in the details, we put up a note here last year when we implemented MACI, and that has all of the references and all of the details about our implementation. Just want to mention that it's also possible to build anonymous MACI with another approach, which is building a 2-of-2 NPC between the operator and the voter. We actually did research like earlier about this one. It's a combination of gobble circuit and oblivious transfer. But so this is earlier, but we never implemented this one just because of the complexity on UI and UX. Just want to mention there is another approach. So after that, anonymous MACI went silent. We did a testing run around like the same time last year, and that was like very small run. Nobody really cared about MACI because last year MACI was not even fully adopted. So we just decided that we will leave it for a few months. But the real adoption, like the first real adoption of anonymous MACI, actually came in earlier this year at East Vietnam. I'm actually very happy that East Vietnam was the ever first community that adopted anonymous MACI. That's so interesting. It's a vibrant community and it's so far away, but they adopted anonymous MACI. And obviously, it went very interestingly. With the Ethereum community, we deployed on EVM. And we had a lot of very happy users. They like attendees and hackathon hackers at the venue, and they like vote for each other. They sign up, they vote, they deactivate the keys, they register new keys, etc. But we have like very happy attendees who actually voted in MACI. So probably I'm running out of time, but just want to mention the next steps of anonymous MACI. So there are a few things we are going to do. 3 things. First, we're going to launch anonymous MACI operator surveys. So this is very important because the reduction on trust assumption of MACI operator is critical. It allows anyone to be able to become an operator on behalf of other communities. So this drastically reduces the cost of running MACI. So I would say like the DoraVolt MACI, like the original one, reduced like 90% of cost of becoming a MACI operator. But with anonymous MACI, we can reduce another 90%. So potentially it could become very game-changing. So the second thing is we're gonna add a MACI judging on DoraHacks. Just because DoraHacks is like hosting so many hackathons, there are a lot of ecosystems and communities using DoraHacks. So the adoption of MACI and anonymous MACI from the open source developer community is very important. But that will be enabled on DoraVolt with IBC enabled. And last, we will implement portable MACI, probably portable AMACI, probably a little bit later. So that will be similar to what we did with MACI for general use cases. Yeah, that's about it. So last thing, don't forget to participate in the largest MACI round. So if you have staked Atom by around May 27, you should have been already given voice credit in the round. So so all of the gas fees will be reimbursed by a gas station, and we're seeing a lot of voters recently. And the round will be concluded on 20th of May. Yeah, hope you enjoy that. Thank you.